Hi everyone, today I'm going to show you my setup on how to test 3D printed items towards torque resistance. So it's a pretty simple setup, and you actually won't be fooled by anyone saying, okay, this is a premium material, so you have to pay 5 times the usual price and it's going to be a lot better. Okay, so here we go. So okay, all you need is a wrench like this one, which is adjustable. Okay, so I have it set to 30, and a vise. So this is a sample. It didn't print perfectly, but yeah, this is a premium material. I haven't tested it yet and I'm quite excited to try it. Right, okay, let me just get it in the vise. Okay, so basically this is just a square. The walls of the square are 5 mm thick. Okay, so this is the initial amount of force, which is at about 30. You can see it on the left hand side. So now I just have to insert it into the print. So the fitting is quite tight, which is good. Alright, so the setup's good. And now we twist it to see if it clicks. Heard that one? Probably, so it clicked. Now I'm going to adjust it to 40. It's about 40. So most of the samples break at this level. Yep, there you go. Okay, so now onto the results. Okay, so it actually split both on the layer and on the wall, which is pretty bad. So this is actually weaker than all the usual materials I use. This was printed on an Polymaker 2 Extended Plus, and the material is PA6-GF, produced by Polymaker. So it's a premium material. It's quite coarse. When you touch it, it's got glass fiber inside, and apparently it's not very good. So I mean, you might say it didn't print properly, and it's supposedly, I'm supposed to print it at 280 degrees at least. I only could get the printer up to 260, so it could be one of the factors, but I've tried other materials from this brand as well and I didn't get very good results either. So yeah, this is the setup. It's actually cheap. So something like this is about, I don't know which currency you go with, but let's say it's about 50 euros. Now this is another 50, and this material is probably somewhere at 60 or 70 per kilo, so it's quite expensive, or even more, I don't remember, to be honest. But yeah, not very happy with the results, but yeah, it is what it is. At least I can have it tested instead of ordering 10 kilos and then end up having a lot of returns from customers because the parts aren't strong enough. What I also found out is that if you're able to produce something using a thicker nozzle, so this was produced using a 0.4 mm nozzle, some of you might be able to tell that. So if you can use a 0.6 or 0.8 nozzle, both will give you about 25% more strength against torque, using the same material. So you can actually get away using cheaper material, and in practice it will be stronger than many more expensive materials, or really premium materials like this one, which is actually a disappointment. So I'm not very happy with this. It also didn't print very well, so the printability is quite low. I wouldn't say it looks it like it didn't get enough heat. It actually looks like it was overheated during printing, so you get all those little blobs. I'm not sure if it's visible. No, not still. Yeah. So you get all those little blobs. That means overheated, but yeah, no, this is not the greatest material to print with. I mean, maybe if you have it in a special environment, then you'll be better, but most of us don't spend tens of thousands on equipment. So yeah, it was just printed on an Ultimaker machine. It was Ultimaker 2 Extended Plus, and yeah, it did handle printing it very well. So this sample was printing for about 5 hours. I had to go very slowly because of the heating issue. So I was slightly underheating it. So yeah, you can just get away by going very slowly, as long as your nozzle doesn't clog, and it didn't. So yeah, okay. So this is everything I had to say. You have a good day. See ya.